Good morning. Thank you for introduction, and thank you for the organizer for giving me this opportunity to present my study and experience in Fukushima. What I'm going to talk about is the role of individual dosimetry for affected residents in post-accident recovery from Fukushima experience. First, I start with some background and motivation of my study. Well, the government has designed the decontamination works and the criteria for evacuation and lifting the evacuation order on the basis of the additional external dose estimates using the simple model proposed by the Ministry of Environment. As you see here, I think many of you already see this equation many times, but this is the very strong impact on the decision-making process in Japan. And the long-term goal under the decontamination policy is to reduce additional annual dose to 1 millisievert per year. And the criteria for the lifting evacuation order is 20 millisievert or less. So that's the gap between the 1 and 20. That's the one of the discussions always going on in Japan. Then people in Fukushima or other public, the annual exposure of 1 millisievert or air dose rate of 0.23 microsievert per hour has been recognized as a safe level. And then this is the figure used in the residential briefing in June 2016 in Iitate village by the government. As you see, the yellow region here is a range of above 20 millisievert. The green region here is between the 10 to 20 millisievert region. Then the light green area is 5 to 10 millisievert region, and the blue area is 1 to 5 based on this equation with some monitoring data. So this is actually regulators need to use because of the manual says so to use this one. But there are the gaps between individual external doses obtained by the personal dosimeter and individual doses estimated by the simple model is already everywhere in Japan, and then and also complicated dose quantities and units for radiation protection cause confusion among general public and even among experts and regulators. So we have a monitoring post and a real-time dosimeter and the airborne radiation monitoring, and also the glass battery dosimeters. So the result is expressed by the sievert, but the meaning of the value is different. So the motivation of our study is just to correctly understand and assess the realistic individual external doses in the region. So the information for the accurate information in the individual external doses needed by the government policymakers or by people providing healthcare and radiation dose mitigation advice, and also especially for the people in affected citizens. For this background, we have started a study. One is understand the realistic individual external doses of individuals in the affected areas, both non-evacuation and evacuation zones, and also the relationship between the individual external doses with activity patterns and the ambient doses based on the airborne monitoring data. Then actually we have developed some tool, it's still pilot tool, to establish a pragmatic estimation to assess and manage the individual external doses, but I'm not going to talk about this, but this is only already on the web, actually not only in Japanese, but if you are interested in it, so let me know. And finally, not only just measuring or assessing data, we want to know the responses from the participants of our study, how they feel about the measured individual external doses or radiological condition of their living areas. So from my talk, I will go over just the general findings of my scientific part of the evidence and a little bit. Then I'm going to talk about some of the lessons or experience caveat to obtaining those data in my study from now on. Okay, this is the framework of our individual external dose measurement, assessment, communication research. Because we want our data to be used in the local municipalities and also the people living in the affected area. So we communicate and consult with local stakeholders from problem formulation to communication and also the decision-making areas. So I don't know much about stakeholder involvement at this moment when we started this study, but as a result, this is a kind of the approach we have taken to get obtaining information and telling information to the public. Then support of local residents is essential for the data collecting stages, especially for our study. Then this is the study participants and the areas. As you see here, we have started this study from 2013. It's about 50 people. That's all living in the outside of evacuation zone. Then after time goes on, some of the people living in the evacuation zone is participated. Actually, they are not living in evacuation zone. They are temporarily visiting these zones, so that we can get more realistic dose these areas, especially the Yamakiya district in Kawamata town and also the Itate village. Both of the areas, the lifting order is evacuation order is lifted. I think this end of this March. So about to date, approximately 250 Fukushima residents participate in our study. Actually, more than 300, in fact. The data we have analyzed and also we have informed consent is about 200 people. So what kind of data we collected? The data we collected is approximate, the period of data collection is about 7 to 14 days. That's about between September 2013 and May 2016. Then the individual external dose, we use the D-shuttle, hourly dose we got, and then you can find the booths for showing the D-shuttle in the coffee break. It's a Chiyoda Technol booth here. So actually, when we started to this study, no English version is available, but right now, it's an English version of D-shuttle is available. So if you're interested in it, just go there. And location and activity patterns of individuals, we use GPS receivers and time activity diary to identify this, and also air dose rate, ambient dose rate. We used airborne monitoring conducted by the Nuclear Regulatory Authority in Japan. Because we use this data, this is available to the public and also that covers the many areas. About this shuttle, I'm not talk about in detail, but some characteristic is that this is long battery life. It's long as 1 year. Also, there's monthly or daily or hourly dose trend as you can find. Right now, revised version of the shuttle we sometimes use is you can get data every 10 minutes or 2 minutes. Then this is very light and a compact size. I'm also wearing this one right now here. And then this is designed to detect the gamma ray. And this shuttle has been used for several municipalities in Fukushima. To date, more than 30,000 were distributed. but I don't see much results these days. And also, this is a used digital project leading by the Ryugo Ayano. This is also the well-known paper. Maybe you may know. This is just read out from Dishato, so the time and those rates. Then you can see that this is in the airplane and other security gate, so that you can see those things here. And also, this is an example of the read out from GPS. So I asked the people to wear the shuttle and the GPS, so the data reading from GPS is, we can do that. Okay. Then we have data from personal dosimeter, and also the data from GPS, and also the time activity diary. So we combined all data together, we can get this kind of data. I'm sorry, this is really hard to see. So this red one or green one, this is the shuttle hourly individual dose rate. Then it's really hard to see. This is green line here. This is the we obtain from the air monitoring with the GPS. So we correlate between the GPS and the air monitoring with the GIS system. Then the time activity pattern. So this color represents the what people are doing this time of time. So it's light green area is the staying inside or the at home. Then this gray area stays outside. So the spatial temporal radiation exposure assessment using the shuttle with GPS GIS technology allowed the identification on where and when exposure occurred. And this is some example of the individual external dosage profile obtained by the shuttle. The first one is we got from Orchard in Date City, which is not evacuated area. So that as you see, people walking outside in an orchard, it's very clear distinction between the staying outside and inside or at home. And the second person, their house is a little bit higher area. So, but when they go out, sometimes the dose rate goes down, and then it's corresponding to the also dose rate also go down. And then this one, the third one, C. This one is a housewife in Fukushima, so there's not much differences you can see here. Then the one in the last, this is the person who commune to the evacuation area to do some outside work at the Itate village in evacuation zone. So as you see from these figures, external dose profiles were depending on the activity patterns and the location of individuals. And then this is you can see from this dosimeter. This is also some example of individual external dose profiles obtained by the D shuttle in Itate village 2015. So as you see in Itate village, right now it's the evacuation order is lifted, but the profile they are visiting Itate for a short time. The colored area in this figure is inside the Itate village, and the white area is outside Itate village. So as you see, that there's marked differences between the people staying in Itate and the outside Itate. So this is one. It's easy to understand the situation in Itate, but also it is very difficult to explain how these differences, the meaning to those people. That's the things I'm going to talk about later. And, we analyzed some of the source contribution to the accumulated dose for individuals. So those data, we have hourly external dose and activity pattern and location. So we can analyze which location, what kind of activity contributed to the most to your total dose. So we show, analyze this kind of data to show, to discuss and share the situation and the people in the participants. And other findings from our study, we relate individual external dose obtained by the shuttle with the ambient dose rate based on the airborne monitoring. So in this one, horizontal line represents the additional air dose rate, and the vertical line represents the additional individual external dose rate. So in the graph in the left represents the study participant from mainly in non-evacuation zone. Then on the right, study participant from evacuation zone. As you see, not much differences in this figure if you consider all the time activities or all the allocations included. But so the ratio here is on average is 0.18, it's 0.14 for evacuation zone. But if we extract the activity pattern is staying at home, and also the staying outside. So the right left side, this is the data we extracted from the people not this one, sorry. As you see here, the 0.6 is the ratio or coefficient the national government used to estimate external dose for make decisions. But in reality, we have some number like 1.18 to 0.14 in the measurement based on measurement results. But if you see the this exposure ratio differences between time spent at home and outdoors, time spent at home, the ratio is the data from evacuation zone and the data from non-evacuation is really similar. But outdoors, the distribution of ratio is much wider in non-evacuation zone, but much narrower in evacuation zone. We assume that because of the decontamination, aerial decontamination in the evacuation zone, of the impact of actually was contributed to this shape here. So that this kind of results also are used to estimate additional individual dose after they return to the evacuation zone. So this is one example we have estimated in Iitate village. We assume the people stay 16 hours indoor and also the 8 hours outdoor. This is the same assumption with government used. And this is based on our results. These are the different regions in the Iitate village. So the number corresponds to the regions. The number 15 here, this is a Nagadoro district in Iitate village. This is still difficult to return zone. And this green one is the one estimate using the government dose estimation model. So which one is used in the resident briefing in the last year in Iitate village. So that's the differences between the data we obtained from Iitate and also the estimate using the government. So there's the remarked differences you see here. And the data we obtained also used in the some of the committee meeting in the Itate village. So the estimates of individual external doses based on results from our study were about 1/4 of estimate calculated by the government dose estimation model. Then, after doing this kind of data collecting, when we returned to the data to the participants, we got some interview with the participants. This is only 20 people in Itate village, so not maybe representing all the people we got information. So some of the questions we ask is, does any radiation dose level you feel secured? What are the reasons? So about 50 or 60% of people answer the 1 millisievert per year is feel secured, because the government indicates this level is safe, or in non-evacuation areas, especially people discussing about 1 millisievert. And sometimes people say, I don't care. Then some say just 5 millisievert because the village goal is this. So that just depends on the people. The feeling of the feel secure is different, as you see. And what type of radiation information do you need to return to your home in evacuation zone? And future radiation dose and also the personal dose information is very important to them to decide return to their areas. And also information that helps my children and grandchildren understand they can safely visit Itate is also the some people who states that the information to judge what data is accurate and trustworthy is many people coming to Itate and talk about many. So just that's one of the things they want. The other questions, what do you think of your personal dose level? Well, many of the people, some people just say that higher than expected. This is very limited people, but many of the people say lower than expected. They thought that their value is much higher. But compared to their temporary housing in Fukushima or other areas, the level is higher. So that's the differences they feel. And also do you feel secured when you see your own personal dose data? This is also, the answer is vary. Major data will surely help me understand and feel secure about radiation exposure around my house, but I haven't decided to return. This indicates that radiation level is not the only element to return or not. And and also some said that I was relieved to know about location where higher radiation levels were measured. So no matter the level of the dose, or someone said I must accept the current level because I need to return to my home anyway. So that's kind of answer we got. And other questions is your radiation condition important element for your decision to your home immediately after lifting evacuation order. So some of the answers here. So many of the participants say that it's a very important element to decide. Then other D-shuttle examples we experienced. Measuring or sharing radiological situations with local people. This is the one example. The district in Itate, about 70 local residents participate measuring the local radiation level with air dose rate and also the level in soil. And also they put a D-shuttle here, so all the information in the D-shuttle is shared with the people. And all the result is in the local report, such as this one. Then Also, some of the people asking us what's the level when we collecting mushrooms or either mountain plants in Itate. So this is some area. So we walk to in the mountains with the residents to show these are the level in the mountains. Okay, we're going to sum up. So the individual dosimetry, such as D-shuttle, play a versatile role in post-accident recovery for residents and authorities. The understanding realistic radiological situation of their life, and the self-protection and resting anxiety against radiation, and selection of effective radiation dose mitigation strategies, and also the future reduction measures, also the important aspect. Now, answering actual concerns from affected residents for everyday life is also the one role with the individual dosimetry have. And the caveat for use of personal dosimetry in the post-accidental recovery, the differences between personal attitude toward measurement data, even when measurement value the same, some participants felt relieved and some felt uneasy, so this is one aspect. Then some residents were concerned when we show the peak dose that's greater than some reference level in the time series data. And also the providing specific solutions for the affected resident to reduce individual external dose based on the measurement may be difficult. We show you the data or peak, but we cannot provide a solution or answer to reduce, because sometimes you have to area decontamination or large decontamination are needed. And other things, once regulatory decision and reference values was set and penetrated the public, it is very difficult to change or moderate initial reference values. And the long-term goal of 1 millisievert of invasive conservative assumption made a great impact on the many aspects. And also the difficulty to explain why is about 1 and between 1 and 20 is okay. So not just measuring, but also important to prepare the system and human resource responding to anxiety of the resident caused after informing the results of measurement. And also maybe needed to provide, maybe implement external dose reduction options by support of authorities. And also authority to utilize the individual dosimetry data to better understand the realistic dose distribution of the population with care of personal information. Especially the D-shuttle was distributed to 30,000, but not really utilized well at this moment. Okay, that's all for my presentation. Thank you.